Many students find it difficult to remember all the VSEPR structures that are taught in AP Chemistry. So we're going to talk about a strategy that many students use to bypass that and dump it really quickly. So first, I'm going to show you what an optimal run of the strategy used to dump VSEPR is in the real world. And I'll put timestamps above if you want to discuss it. But for now, I'll let this play out so you can see what the potential of this is. It's important to realize when you talk about any dumping strategy on a test is that there's an inherent opportunity cost to it, and the fact that in the time you spent dumping this table could actually be used to just take the test. But typically speaking, for VSEPR, there's a lot of information, and once again, you could just flip back to your first page of your test and save so much time and guesswork because you have a fully accurate table rather than jogging your memory halfway through the test. Furthermore, even as I go through these bond angles, you'll find that something like bent doesn't even share the same bond angle depending on how many lone pairs and bonding sites it has. So this really helps students with that as well. Feel free to pause and write down stuff if you need to. We're going to start with a 6x6 table, and we're going to have the top be lone pairs and the left side be non-bonding plus bonding sites. The first thing we're going to mark is the linears and the bents. So it's going to go in order of linear, bent, bent, linear, linear. The stuff above these bents are literally not possible. So now we're gonna go down on the zero lone pair column. 3 here, right? So you can just remember trigonal planar. We have 4, that's gonna be tetrahedral. 5, I usually think 2 plus 3, so trigonal bipyramidal. I just think tri, which is 3, and bi, which is 2. 6 is octahedral, so you can figure out a way to memorize that. All right. Now from here, the next thing we're gonna do is gonna be the 1 lone pair column. The 1 lone pair column is gonna be kind of the hardest to remember because there's not really anything for it. On the 4 and 1 column, it's gonna be your trigonal pyramidal. And it's gonna be seesaw. And it's gonna be square pyramidal. This time I will spell pyramidal correctly. And the way I kind of remember this is I create little symbol thing because that's a triangle, that's like a seesaw, and that's a square pyramidal. So I just think about this. It can be a little confusing because you'll get square pyramidal and square planar confused a lot because they're right next to each other and they're literally like the exact same name almost. But you'll get used to it. So then we have T-shape up here and T-shape down here. And then this last one's gonna be square planar. Well, now the thing is, after I finish this, there's one more thing that you typically tested on with bonds, and that's bond angles. And as we see here, we don't have bond angles. So the chart actually does help you a little bit. There's some heavy lifting you have to do on your part, but it's overall better than not having it at all. Now, sometimes a test questions won't just ask you for the name. They'll ask you for the bond angle. So it's really important for you to learn and memorize. The first thing you need to know is that linears are always going to be 180. This is always true, no matter what linear it is. Now moving on to the 3 row, we have trigonal planar, which is going to be 120, and then bent, which is less than 120. Next, in the 4 row, we have tetrahedral, which is 109.5. Then we have trigonal pyramidal, which is less than 109.5. And then we have bent, which is less than 109.5. Remember, just because it's bent doesn't mean the bond angle is the same. And furthermore, if something is polar, which means the dipole moments don't cancel out, it's going to be having a less than sign. Now, if you're beginning a sense of pattern, the trigonal bipyramidal is going to be 120 and 90. It's symmetrical, so it's not going to be having less than sign. Then we have seesaw, which is less than 120 and less than 90. Then we have T-shape, which is less than 90. And as a matter of fact, all T-shapes are less than 90. Now we have octahedral, which is 90, which is to be expected because it's nonpolar. Square pyramidal, which is less than 90. And now we have square planar, which is just 90, which may seem strange, but if you actually wrote out it, you'd see that the dipole moments cancel out, so it's actually nonpolar, so there's no less than sign. And if you need help remembering that, square planar has similar wording to trigonal planar, which is also symmetrical, and square pyramidal, which is polar, has similar wording to trigonal pyramidal, which is also polar. As far as the chart goes, that will be it. If you do want to try using this on a test, I would recommend practice. You can rewind the video to watch more.